Hello everyone. So today we'll learn heatsink on Ansys software. We will design the model for that, and also we're gonna go through step by step how to do meshing and the state thermal analysis. So this project will be based on two different models. So as you know how the heatsink work, we will try this analysis with two different models. So one model will have 11 fins on it, another one will have 5 fins on it. So today, as most of you already did in our last lab, did 11 fins geometry. So today we're gonna go through the 5 fins geometry, and also we will try to show the geometry one more time on this 5 fins model, and you're gonna go through the meshing and the steady state thermal analysis. So in order to start, as you know that we have to select a steady state thermal, and we have to drag it to the box over here in order to start our analysis. So we're gonna see these steps in order to complete our analysis. So we're gonna go to the geometry, and we're gonna do a right click on it, and we will select simply new space claim geometry from there, and our space claim software will pop up. Usually takes a little bit time to pop up, but it's not gonna be that much long. So let's just wait for that, and we can go ahead from there. Okay, so as we can see that our space claim software for the geometry is popped up. So you will first select a view, a plane view, in order to draw our geometry. So we'll go over here and we'll enable all the options for us. So from here, I always prefer to select a top view because it's easy to draw and kind of also easy to extrude your geometry. So, and after that, we will select rectangle in order to draw our sketch, and in order to define the geometry from the center of our graph. So we're gonna define rectangle from the center option, and we will come to the center of our graph, and we will simply select it and drag it down towards our geometry shape. So from here I will define, sorry, let me do it one more time. So from here I will define the width of the 50 millimeter, and the length will be 130 millimeter. Okay, so we got our structural shape for our geometry. Now we're gonna draw 4 holes on it. So you're gonna come over here on this corner, and we simply click on Shift button, so we can enable the 2 dimension for in order to draw our geometry. And as we also mentioned in our previous class, the in order to select the location for the hole, we have to define it 5 millimeter by 10 millimeter, and as you can see on the screen, it is 5 millimeter by 10 millimeter, 5 millimeter width and 10 millimeter length. So that's where our hole will be. And now we will simply click on our mouse, and we've defined our space where we want to drill the hole. So from here we have to define the diameter for the hole, so which will be 5 millimeter as well. So we'll define it and we'll press enter. So we got our first hole. So same way we will repeat for the 4 holes here. And again, the values can be in a negative form or positive form, so we always have to remember that whatever form it is, we have to keep that one. So again, 5 mm. Let's just finish all four of them. So for in order to do select the place, you can do it two way. One is with the help of your mouse, another one is simply defining the numbers. So sometimes when you use our mouse, we for a slight shake it can be dislocated. So it's always better to define with the numbers because it's not going to go anywhere else. But you can do both the ways, that's up to you. So as we have drilled our holes, so now our geometry is ready to give it a base form. So we're going to take it to the 3D mode over here, and I will simply, in order to make it easy for myself, I'm not gonna use my mouse to give it a 3D view. I'm simply gonna click on the H button from the keyboard, so that the geometry itself will be like in a shape that I can just easily select it and extrude it to the desired best base thickness. So I'm gonna select the y-axis and I'm gonna try to pull it up, and I will also hit on my space button from my keyboard in order to define it. So I'm gonna give it to 5 mm as well for the thickness. Okay, so now I'm gonna go back to the geometry again, and I'm gonna again select the top view in order to see my sketch panel the way I want to see. And now I'm gonna select the rectangle again, and I'm gonna come over here, click over on my geometry, and again from this corner I have to give define a gap on both these sides, from that corner to up until like somewhere here, like 9.75 mm, in order to give the space for the holes. So I'm gonna do that. I'm gonna same way simply click here. For the length it will be 0 because I'm not defining the length here, I'm just giving a gap. So I'm gonna go to the width option and I'm gonna select 9.75 and enter. No, my bad, it took a different direction, so let's do it again. So I'm gonna do it negative 9.75. That's the length will be 0 and it will be negative 9.75 millimeter. So I got my gap here. Now I'm gonna draw my first fins. So in order to do that, I always try to move my mouse in a direction where I want to draw, so that it doesn't go in a different direction. So I'm gonna do, that's the reason I moved my mouse on the left hand side, because I'm going from right to left. So over here it will be the length will be 50 mm, and the pass width will be 5.5 mm, and that's my first fins over here. So same way I'm going to do that, but for reference, like I did calculated the gap between fins. So as we haven't gone, I was just thinking that as we haven't didn't calculate the gap in our class, so let's just draw the regular 11 fins one, so that we can keep it simple then, and after that we can also try the 5 fins one. So the length will be 50 mm, and for the gap will be 5 mm. So I draw my one fins and one gap already. So let's do it one more time. For the fins, it will be 5.5 and now a gap, and we'll complete all our 10 gaps and 11 fins together. So if I forget, like if I have drawn the fence or the gap, we can always do this, the dimension, and we can always check. Oh, see, I did a mistake here. So we can always check with the help of the dimensions, like what we sketched. So this one will be a gap, but I draw fins instead of that. So let's just go back and give it a gap dimension. Okay, so you can always check it with the help of the dimensions, so that you get to know that what you're actually doing. So we are almost at the end of our geometry. So a couple of more gaps and fins, and we're done. So that's our last fins. So we have drawn all our uh, gaps and fins. So now we're gonna go to the 3D mode again, and we'll again click on the H button from our keyboard, and now we will select all our fins in order to give it a to extrude it. So let's select the first fins, and in order to select all the fins together, we have to press and hold the control button and select all our fins at once. So let's just extrude all our fins. So let's do it like that, and I will click on this space button from my keyboard, and I'm gonna define it to 70 millimeter. That's the length of our fins. So as you can see that my drawing is done. That's my heatsink model with the 11 fins. And now I'm gonna simply go to the file option in order to save my design. So you can go to the file option and save it from here, but we're gonna click on Control S, and we'll give it a name. Let's say heat sync I already did a lot of heatsink projects, so you can see on the drop down menu that those names also showed up, but we're gonna give it a different name. Heatsink, let's say heatsink for thin. Okay, heatsink for thin, that's the name for my file. Let's say for thin 2.0 and save it. So I have successfully saved my geometry. So now I'm gonna go to the model and click on the edit option in order to go for the meshing. Oh, sorry, but I think I also have to, I forget to tell you that I have to also close my Space Claim software first. Yep. So as you can see that I'm on the meshing part of my geometry right now. So the model we draw, it will automatically pop up on this option. It takes again every step. So when you go from one step to another step, there is a different software for that, and it takes a little bit time to for that in order to for that software to be ready and pull up your model from the database. So it takes a little bit time. Okay, so we can see that it's over here, it's ready for us. So now we're gonna simply select all the surface of our model. We cannot leave anything behind. In order to do a nice meshing, we have to select everything. So let's just do that, and then we'll go for simply for this meshing. Okay, so we have selected everything. Now we're gonna go and click on the solve, and as you can see over here that our meshing went through the 100%, and it did the meshing for us. But in order to play with the meshing option, you can simply click on the meshing, and you can define the sizing and the options, what type of meshing you want to do. You can even change the angles or everything. You can play over here. So you can go medium, hard, or meshing matrix. You can do a lot of stuff over here. So they're like the whole world of meshing is open for you for on this table. You can just simply have to define or say whatever you want to do, and it will do for you. So let's just go back to our file right now, because so we did meshing. Now we're gonna close the meshing, and we're gonna go back to our workbench software. So you can see that our meshing model is right click over here. So every time you successfully complete one step, it will be right click mark on that more step, so that you get to know that you did it right. So now we are gonna go back to the our engineering data, and we're gonna define the materials we want. So for that we click, as you see that I clicked on the engineering data, and now I'm gonna click on the engineering data source from here, and we're gonna, from the top table, we're gonna go and select the general materials. So you're going to simply select the general materials. So as soon as we do that, the second table on the bottom, it actually gives us all the materials it have in the list. So we're going to select, you actually have to add aluminum alloy from here. So we, in order to add our material aluminum alloy, we have to click on this plus button here, and as soon as we click on the plus button, that we're gonna see that there is a bookmark sign over here, and that defines that we have successfully added our material to our geometry. So let's just go back to our project file, and as you can see that we have defined a new material, so our meshing option is not there anymore, so we have to update our meshing over here. And in order to do that, we're gonna simply click or right click on the model option, and you're gonna go and select the update and gonna click on update, and it will do update meshing for us, because we don't need to go and do the same thing again. We just simply defined materials we want, and we did it, and we update our meshing from there. So now we're gonna go to the setup option. So we are at the end of our work right now. So we're gonna go to setup, and you're gonna click on edit, and you're gonna click on yes. So as we can see here that it popped up with our model, with our geometry. So from here we have to do two things. We have to define our heat flux and our convection. So as you know, the way the heat sink works, it's gonna sit on the top of the hot component, and it will try to take the heat out of it, and that's why this bottom part will be the um, this bottom part will be our heat flux. So we're gonna simply select it, and we're gonna go and click on this option. It says heat on the top down menu bar, and we're gonna click on that. We're gonna select heat flux from the drop down menu bar, and that's our gonna be our heat flux. So we have just selected our heat flux. Now we have to uh, give it the magnitude of that, which is gonna be 1000, and we also have to select the geometry and apply it. So we have successfully selected our sorry, we have to go back maybe one or two steps. I unfortunately selected these holes also, so it's not gonna be that. It's just gonna be the heat flux. So let's just delete this one. So that's how you also fix it. Like you only select the bottom surface for the heat flux. So let's go and do the same step again, heat flux, and give it the magnitude to 1000, and select the geometry and apply. So as you can see, now I corrected it, and my heat is giving me heat flux is giving me a direction to the topwards. So the heat will come, and this will be sitting on the top of the hot surface, and the heat gonna go from the bottom to the top. So that's the way you also always get to see that if you are in a right direction. Direction is very much important. So as you can see that when I select these holes, my direction was going this way instead of going to the upwards. So that's how you have to be careful, and you have to always like make it confirm that what are you actually doing. So now we're gonna select the rest of it to define as our convection. So same way, press and hold your control button and select everything. I think we have selected everything. Now we're gonna go to the top down user manual and we're gonna select a convection from here. And as you can see, we selected the convection, and now we're gonna define, we have to define two things over here. One is film coefficient, another one is ambient temperature. So for the film coefficient, it will be 25 degrees Celsius, and we'll define the ambient temperature to 28 degrees Celsius. And again, the geometry you have to define and apply. So as you can see that we have also defined our convection as well. So we're going to select on the steady state thermal, and as you can see over here, it is there, the heat flux and the convection, both of them are there. It also giving us point A to point B and the direction as well. So we can click on the solve, and it's gonna be ready in a few seconds. Yep. Now we're gonna go and close. No, we can simply go from here as well. We can select on the solution, and for the solution we have to define what we're actually doing. So we are doing a thermal analysis projection here. So you're gonna go to the top down user manual, and you're gonna select thermal and add temperature here. And now we're gonna simply select go and click on the solve option in order to do the analysis for us. So as you can see, it did the analysis for us. As I kept it simple meshing, you can also go with the CFD or hard meshing. You can play with the meshing by yourself or with the instruction of the instructor, how they want the meshing to be done on the experiment. And you can see that our temperature has changed a lot. So our minimum temperature is on the top over here, which is saying is 30.254 degrees Celsius, and our top temperature max is 31.836. So you can also see a table here with the minimum temperature, maximum temperature, and the average temperature as well. You can also come and click on the animation button over here, and you can see how the heat actually is coming and react the way it is reacting on the heatsink. So the heatsink actually absorbing the heat and taking releasing it on the air. So that's the way the heat is actually touching the base, and it is absorbing in the whole structure. So that was all for today for our heatsink steady state thermal analysis. So we're gonna have to do the same thing with the 5 fins as well. So in order to do with the 5 fins, we have to calculate the surface area, and we're gonna have the same model, same design with the same thickness. The diameter for the holes will be the same, the gap from the hole to the first fins will be the same, both the sides, and the width and length and thickness, I mean everything for the fins will be same. The only thing will be changed is the number of the fins and the gap between the fins. So these fins and these fins will be there, but we have to take out these 9 fins, and you have to calculate the surface area, and you have to give 3 fins over here, and the gap definitely is going to increase. And you have to do the same analysis again in order to see how the temperature is reacting. Is it going to go up or is going to go down? Is going to take more hits, is not going to take less hits? That's our question. So we'll go and definitely do that and see what is the answer for us. And that was all for today. Thank you so much, everyone.